Alright, so this is going to be a game I'm going to be making in Raylib. Essentially, got a guy right here, something like that. And you got a platform, and the platform is going to go up, and you got to move like left to right, probably jump or something. Maybe like ground pound down or something to go faster. And you got to avoid the spikes up top and down below. And then, or I guess maybe there's just a pit down there. And then there's other platforms that spawn that come up. So I think that'll be fun. Alright, so this is Raylib. This is the template project. Or pretty much with my setup by following tutorials. So just compile it and run it. There it goes. Okay. Alright, so what we need is to actually learn some stuff. So probably best to make some kind of platform for the player. To the camera. Here we go. So we can just take this, just reference it, go. Oh, blocking must mean if you can go down? Oh, that you can, okay. I see now. You can jump up from the bottom platform. Okay. So I don't need that. Rectangle rect. I'm not going to do the camera here. Okay. So I'm going to just do something similar to that. Struct player. What do we need? We need a vector2 position. Probably vector2 direction. Is that what we had in here? Is that what they had? Float speed. What was the other one? Can jump. Right. Okay. Can jump. Just going to copy it from there. And so, player. So I'm just going to make a player. So let's make this capitalized. Player player equals 0 player dot position equals vector 2. Guess in the middle of the screen. So that's going to be vector 2. So x and y. So x is going to be the width, so screen width divided by 2. So I'm going to put them in the middle here. Yeah, screen, just for now, screen height divided by 2. Player.speed equals, say 100. Player.canJump equals false for now. So now we need to draw the player. So we can just do like a rectangle or something. Rectangle. So it needs like the position. Yeah, and then the width and the height. Okay. Player sprite, just call it like that, equals player.position.x, player.position.y. We'll do like 100 pixels by 100 pixels. So now we need to draw him. So we're just going to comment this out. Draw rectangle like that. Okay, cool. Player sprite is the rectangle. Color will do blue. Alright, let's play it. That's pretty big, so I'm gonna half that. I think it's alright for now. So it's not directly in the middle of the screen here. It's just the top left corner is in the middle of the screen. So I'm going to do minus 50 divided by 2 is 25. Because we want to go to the half, to the middle of the sprite, just subtract that. Or middle of the rectangle, really. And that should put it in the center. So now we need to make it move. Moving the player left and right. So, what do you think here? I think it's going to be if player input. I forget. This is why this site is so helpful. We get a cheat sheet. Return related functions. Here we go. That's for the mouse. Here we go. Is key pressed? It's been pressed once. You probably want to check if a key is being pressed. So is key down. So is key down. So this is going to be going to the right. Key underscore D. And we're going to do, so this is going to be the x-axis. So player dot position dot x. So if we're going to go to the right, so plus equals player dot speed. We probably need to cast that to an int because the vector is a float. Vector 2 is a float. Yes, it is. Times. I was going to do like the delta time, but nah, because it's an integer, it'll be alright. Paste that right here. We're going to do A if we're going left. We're going to do minus now. We're going to see what happens here. No, nothing's happening. I set the player T speed to 100. Hmm. Hmm. I think I'm doing the same thing. Let's try this. Let's just try debugging. Print, draw, text format, %d, %d, player, I'm gonna do int player dot speed. Alright, position 0, 0, font size be 20, color, color be blue. This is just to see if it's converting or it's casting it properly to an integer. Yeah, it's 100. Let's do player.position.x. Maybe it's just not being updated to the... Oh yeah, that's probably what it is. It's just not being... I'm not updating the position of the rectangle here. Yeah, that's what I'm doing wrong. Uh-oh. Oh, you can only do that during initialization, right? Dot x equals player dot position dot x minus 25. Oh. All right. Times time. It's not delta time. It's just called delta? No. Mm, where is delta time? Get frame time. That's it. Okay. Get frame time. Let's try it here. See what happens. It's a lot better. Okay. So now I need to make him fall. So we'll just do what that example did. We'll just define gravity to be 10. So let's just do a constant downward force. Update sprite. All right. Falling down. So it's just going to be like a constant thing, I guess. So if player dot can jump equals false, that means we're falling. So I'm going to do player dot position. Dot y plus equals plus equals gravity times get frame time times gravity. We're just going to do gravity squared times gravity. Probably should have put that above the update. Okay, falling down. Right there, and then we're going to update the player sprite. Player sprite dot y equals player dot position dot y. Oh, minus 25. There it goes. Look at him go. So now we need to add some collision. I think there is a collision. Oh, I think there's like a collision thing in here. Probably passed it or something, but it all looks way too complicated for me right now, so I'm going to look for the rectangle. It's like an overlap function. There we go. Check collision rex. Rectangle rec 1. Rectangle 2 rectangles. Cool. Alright. So, well, actually, first off, I'm going to prevent it from going past the floor. So if player sprite.y plus 50, because that's the height of our square from the top left corner. So I'm going to put that in parentheses. Is greater than screen height player sprite.y equals screen height. So something like that. Let's see if that works. Oh, right. What am I doing? Equals screen height minus 50 to keep it 50 above. 50 pixels above the bottom of the floor. Let's see what happens. Cool. Alright. And at this point, we could probably just turn can jump off, but I'm not going to. Now for jumping. How am I going to handle jumping? Because I will need... How do I clear everything here? I just delete it all? New. And save. So, I have that square right, and I want him to jump, but he also needs to fall down. Which means that probably need to implement some sort of velocity. It's probably what I need to do, because eventually he needs to start going up until he like reaches at the top up here or something. Just that's him right there, and then he will fall down, back down. So I probably could make some kind of velocity variable. Yeah, let's do that. Let's do that. Some kind of velocity variable that is constantly affected by gravity. So we're going to do, I guess we'll just put it in here. We'll just do vector2 velocity. And we're just going to leave it at 0. Player dot can jump is true, and we hit the floor. What I'm going to do is instead, I'm going to comment this out. So instead, player dot velocity dot y, which says 0, plus equals pretty much this stuff up here. Right? We'll probably just do that for now. And then we're going to say that the player dot velocity dot y equals 0. Right? Okay. So right now, wait a minute, what am I doing here? Isn't vector 2, are those ints? Are these bools? Or floats? Yeah, they're floats. Why am I casting this to int? Oops. There we go. I don't need to cast that to int. That doesn't work. Okay. So now I need to base the player movement based off of the velocity. So I'll just do jumping first. So if it's in the air, equals, okay, so I'm going to do, so I'm updating the player sprite, update player position. So player dot position dot y plus equals player dot velocity dot y. We'll do that. Let's see what happens. Oh wow, he goes down very fast. Okay. So I'm gonna listen gravity here. Gravity is gonna be 5. Okay, cool. So it actually looks like there is some kind of acceleration. That's pretty cool. So now we're going to ask if he can jump, or see if we can jump. So if is key pressed, key underscore space. So if we press the space bar, we're going to do player dot velocity dot y. Equals, we'll do some sort of like jump height thing or jump velocity. So we'll do like float jump velocity, do something like that. So player dot jump velocity equals 50. Let's try 50. Equals player dot jump velocity, and we also want to be grounded. So if we press space and player dot it or can jump equals true, we're going to be able to jump. Let's give it a shot. Let's see what happens. Doesn't appear to be working. We're also going to say like player can jump equals false. Let me try spamming it. Oh, I know what I'm doing. I don't want to. Where did I put it at? I want this to be negative because I want him. I'm trying to jump up. All right. We'll change gravity back to 10. Okay, that's cool. I can't just... Okay. So I'm going to change this down to... We're not going to do negative 50, we're going to do negative 25. Okay, that's cool. Okay. I'm also going to make the left and right a little bit faster. So now I'm going to do player dot position dot x plus equals player dot velocity dot x. So I'm going to do kind of like a acceleration type deal. I'm not going to do... Yeah, I'm going to do that because we're not accelerating. Well, we will be, but it'll be dependent on the velocity, I think. So I'm going to bring this down because we're going to add more to it. So this is for left and right. So I'm just going to comment these out just to keep them around for reference. So I'm going to say, I'm going to do like a ternary operator. I'm going to do player.velocity.x equals, I'm going to do player.velocity.x less than, we'll probably do like some kind of max 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 move velocity. And we'll set that to like player dot max move velocity equals 10. Because what was I adding here for the left and right? Just player speed. What was player speed? Did I set that to 100? Okay, we'll just do 100 then. Actually, no, this would be like the acceleration. I'll call this acceleration. Acceleration. Did I spell it wrong? I probably did. Let's then player dot max move velocity. I'm just gonna quickly look at what a ternary operator is. Ternary operator. Ternary operator. Okay, condition. Okay. Condition question mark. So this is if it's true. If it's less than, so we're going to say player.velocity.x plus equals player.acceleration. And if it's false, if we are not less than the max move velocity, then we're going to set it equal to it. So velocity.x equals player.max move velocity. That's what we're going to do. And just going to copy this over. No, no. Oh, actually, plus, no, I'll just do equal. Equals self plus. This makes more sense. Okay, so we're setting the x velocity to either itself plus the acceleration or just the max movement velocity, dependent on this if statement right here. So now we're going to do the same thing down here, except we are going to subtract I'm going to do greater than, because if we're going to the left, that means that our velocity is going to be in the negatives. So if we are greater than the negative of this, actually we will be. So if we're, no, it is that. So if we are less than that negative number, it's just going to be that negative number. Or it's going to keep on subtracting the player acceleration. Okay, let's see. Let's see if this works. I want to see what happens. Probably won't work right off the bat. My logic is probably... Ooh. Okay, yeah. Logic is flawed. Okay. I think I know what needs to be done. I think it needs to be this. Oh my gosh. Okay. Okay, hold on. Acceleration should not be 100, it'll be like 10. Max movement velocity is going to be... I'll still keep it at 100, just to see what happens. Should probably lower that to like 50 or something. Whew, whew, it is floating. Okay, hold on. Set that to like... I'll set that to 10, actually. This will be 5. The acceleration will be 5. Oh, probably need to multiply this by get frame time. I think this will make it a lot smoother in terms of acceleration. Or, actually, instead of including it here, include it here. Nah, I'll just put it right up here. It'll make more sense. Times get frame time. Because this is actually like the movement. There we go. Let's give it a shot. Okay, yeah, it's been... Oh. I wonder why it moves left faster than it does to the right. Should be the same. If the velocity going right is less than the max movement velocity, then we add to it. Otherwise, it's the max movement velocity. Or, if we're going left, so this should be negative, and it should increasingly become negative, which means that it is technically greater than that negative number. Then this should be greater than this, starting out. Let's do max movement velocity. Let's do 50. Let's see what happens. I'm gonna add some more collision right here. We're gonna do if player sprite, no, player dot position dot x is less than screen width. Player dot position dot x equals 0. If player dot position dot x is less than, hold on, if it's greater than screen width. So this needs to be plus 50 because that's the size of our little guy. Greater than screen width. Player dot position dot x equals screen width minus 50. We'll do that. So that way I don't continuously go off. Never mind. Here's a flaw in my code. If player.position.x is less than screen width, oh, it needs to be less than 0, not screen width. The doy. Oh, that doesn't work. I still don't know why I'm going left faster than I'm going right. Player. Hmm. Hmm. Jumping is still pretty satisfying. I probably need to do like jump buffering like Celeste does. I think that'd make it more satisfying. If player.position.x is less than 0, because it should be, I guess it's the mill right here is where I'm technically drawing it at. Player.position.x. Have to be minus 50, wouldn't it? No, it still goes off screen. Okay, that's something there. Why is it only doing it halfway though? Because it should be 50. That's how big I made it. Mm, oh dear. Hmm. Technically, it just needs to be 25. Hmm. Because what it's should be doing is there's just no easy way to just delete everything here. So let's say this is like the edge of the screen, right? And so we have the box. And so technically the player position is in the middle of the box because that's where I'm drawing it at. So when I go that way, it should be 25 pixels that away, 25 pixels that away. And so so in this corner here, 0, 0, so that's the X and Y. So that means that this right here, this whole length, is the screen width. So if this minus 25, so this, whatever the position, my current position is, minus 25 is, it should, if it's less than 0, it means it's off this away. It needs to be set to 25. That's like the halfway point of the square. So if the position.x is 0, that means like it'll only show like half of it. But if it's 25, that means it should show like the full thing. Nope. Wonder why. Let's just do a little bit of debugging here. So let's say that we're going to draw this here. Yeah. Actually, we're just going to do floats. So 0.2f, just to get an idea. Okay, so it's 25. But if it's 25, we should be able to see the other half square. That's interesting. As soon as I press right, you can see the whole thing, and then it starts incrementing up. So why does it disappear then? I wonder if it's continuously still trying to move, right? Because the velocity is still... What if I add friction? So I think though, what I should try tackling first is probably the left and right movement, because for some reason it moves left a lot more than it moves right. I wonder if it's because... No, that can't be right. Um, so if we are... Oh, I know why. This is wrong. So if this is greater than the negative number, then we add that, and okay. 'Cause it was just immediately just pushing it over to like the max velocity. There we go. Okay, that's why. Okay, so now... So now I'm going to do this. So, because I think we're still moving to the right, I need to just set the velocity to 0. Player.velocity.x equals 0. This needs to be 25 anyways. Plus 25 minus 25. I'm still thinking it's in like the top right corner, but no, it's in the middle. That's where I'm drawing it at. Player.velocity.x equals 0. Let's try that. And we're going to set that the max move velocity is 50, but we're going to increment it by, let's do 20. Let's just see what happens. So let's put this back to 100. Oh, I put that to 10. Stop it. 100. Okay. We're gonna do 500. The max move velocity. Kind of just keeps on going. Okay, cool. Stops right there, just like I wanted. Let's try the other side. Stops right there. Okay, cool. So pretty much right now it's just kind of going on without me, and I'd like it to stop as soon as I let go. I think I'm going to scratch this for right now. And I'm just going to do this. Player dot max move velocity. Probably just needs to be set to 100. And going to get rid of that as well. Yeah, maybe I'll put this back to 500. I think I just didn't like how you were able to move on a dime, but we'll look at that later. We'll look at like friction and stuff later. Yeah. This feels nice. Really shouldn't be doing that. So I put the wall detection stuff all the way at the bottom, so it should be running that last. But oh well, I'm not going to worry about it right now. So now, I think we need to be making the moving platforms. So those are just going to be a bunch of structs right here. So struct type def struct form platform. So we're going to have a rectangle in there. Rectangle. Let's probably just call it. What should we call it? Dimensions. Like dimensions. Float speed and vector to position. That's what we'll do. And so we'll probably just make like a bunch of these, randomize the position and respawn them out and stuff. I think I'll do that next time.